So hi everybody, nice to meet you. My name is Eyal Beeman. I'm the VP product for DevSecOps. I've been with the company for about a year and a half now, and most of my team is based in Israel. In addition to that, we have Sharon in my team based in Sunnyvale. And so what we'll do today with my session, we'll give you a quick high-level overview of supply chain security, the challenges or the risks, or what is supply chain all about. And then we'll get into a high-level perspective or overview of what does JFrog do about it, or what is our position or our vision around our security offering. So for the sake of this exercise, for the next couple of minutes, I want to have some sort of an open discussion, and I hope I can hear you guys from the room using the mics. But let's all think of ourselves for a few minutes as if our software product is an F22 aircraft, which is considered to be one of the most advanced aircrafts on the planet, and second, one of the most secure ones in terms of when it comes to aircrafts. So if you are now a black hat in the sense that you are trying to attack or to hack an F22, so give me some ideas. How would you go about this? How would you try? Say you want to take over a single plane, an entire fleet of the U.S. Army, whatever. How would you go about this?
I mean, there are lots of different multifaceted ways of doing that. Obviously, you have primarily software. You have a human element as well, in terms of humans being the weakest link in perhaps the supply chain. You have all of the different components that make up the aircraft. So this could be to do with a particular piece of software that's manufactured, a particular part for a plane, and that could become defective as a result of, the composition of a piece of plastic or a piece of metal that's required to make up the aircraft. Those are three that I can think of.
So you're saying, so let's break it down. So you're saying I can attack this in three different dimensions. I can go after the person, the human in the middle. I can go after the software that is part of what's running the aircraft, or I can go after a piece of hardware that I can use to take over. Fine, that's perfect. So say you have these three different dimensions. What can I do? Let's talk about, for example, hardware, just for the sake of this discussion. What would you do? So say you want to attack the plane using hardware. How would you go about this? Maybe other people in the room as well. Other people.
Infiltrate within the supply chain, maybe has the lowest barriers of security, right? One of their suppliers that and drew them, Trojan horse into the rest of the system. That's what I would want to do.
I think you said two things that are, and I'll try to categorize them. First of all, another dimension to look at things is like a first party versus a third party versus call it an outsource or a vendor. So if Lockheed Martin is the manufacturer of this plane, we can go after something that is manufactured within the Lockheed Martin factory, or we can go after a third party or a vendor that Lockheed Martin works with and buys a piece of equipment or a piece of software, a piece of a component. So that's one dimension. Another dimension. So we spoke about hardware, software, the person in the middle. We spoke about first party and third party. First party meaning stuff that is happening within our Artifactory, if we are Lockheed Martin, or a third party. And then you said something about a Trojan horse. So a Trojan horse is to call it a different way, is to plan something bad that is later on can be I can take advantage of for my own purposes as a hacker. So that's like something that somebody will do to plant a Trojan horse or whatever it might be, so I can take advantage of it later on. Is there anything else I can do without me doing something actively to the plane, changing the plane's components or software pieces? Is there anything else I can do to try and hack the plane?
Radio transmission to do blocking. So I could block traffic, I could block the identifiers, etc. But so I'm not trying to attack the aircraft directly. I'm trying to attack its environment.
Perfect. So another thing that might happen. So first of all, if I'm looking at this, one thing that wasn't mentioned, before I say that, there's two different it's very high level. For the AppSec geeks here, that's not as precise as it might be in real life, but just for the sake of the explanation here. But basically, if I'm an attacker, I can either plant a bad thing in the aircraft, or I can leverage an existing problem which we haven't talked about so far. Meaning there might be a bug or a backdoor, not a backdoor actually. A backdoor is something that is intentional. There might be a bug that I can as an attacker I can take advantage of in order to take over the aircraft. So it doesn't necessarily have to be something that was done with malicious intent beforehand. With that type of intent, it can be a bug by some developer or a bug by some engineer that manufactures something bad within the call it, for example, something with the screws or the actuators of the plane that I can find out about and I can leverage on. And the first thing I'll do, regardless if I want to plant something bad within the aircraft or I want to leverage something that is existing, I will learn the plane carefully in its parts. Meaning I cannot just plant something within the plane without knowing how it's built, so I can know what can I do about it and swap something out or do something bad with it. And in the case of leveraging existing problem, I have to figure out what the plane is. I have to break it down to all its components in order to figure out some sort of vulnerabilities within the plane. So I can either plant something bad in a third party, or I can plant something bad directly in the factory. So let's ask a quick question about this. What do you think is easier, or let's call it more ROI? What's the best return on investment for me as a hacker? To plant something bad in a third-party component of the aircraft, or to plant something bad in the first-party component, which is manufactured by Lockheed Martin themselves? What do you think? What's easier? What's better for me?
Third party.
The one that has the most exposure to other areas.
Right. So generally speaking, the general thought process is as far away as the component is produced from my own environment by a third party, and those third parties have their own third parties and so on. So like I can buy an engine from somebody, and they buy the parts from somebody else, and they buy the parts from somebody else. So the general thought process is as far away as I go through where it's manufactured by myself and controlled by myself, the riskier it is, and the riskier it is for me as a Lockheed Martin, and the easier it is for a bad actor to take action. There is a caveat for that. I'll just give an example just to tease your brains. For example, the operating system of the aircraft is I forgot the name of the manufacturer themselves, but it's called Integrity, the name of the operating system, which is of the aircraft, which is manufactured by a third party. So think of there's a company that builds an operating system for an aircraft. It's called the Integrity operating system, and that is considered the most secure operating system for aircraft on the planet. And the reason why Lockheed Martin is working with that type of vendor is because of the value that they provide in the form of one of many other things, but also security. They buy the most secure operating system for somebody else because their assumption is that they are not experts in that, and somebody else is the expert in that, and we'll buy that from somebody else, we'll outsource this. So generally speaking, you guys were right. If I'm going to the third party, that creates more exposure for me, but there are caveats to that. There are exceptions. So that's on the aspect of planting something bad. When it comes to identifying something which is existing within the airplane, there are two types. There's this type of breakdown that we'll talk about for a second. First of all, I can take advantage of a known problem. And the known problem can be either in the first-party component that is generated by Lockheed Martin, or in a third-party component that they use. But it's a known problem, meaning that it has, for example, in our type of terminology in JFOC, or not JFOC, in application security is a CVE. a common vulnerability enumeration. So it's a known issue that basically everybody knows about. And I can, but I can still, if it still exists within the airplane, I can take advantage of it as an attacker. However, there can be an existing issue which is not known, and it is only known to me. Meaning, I did my research really, really well. I invested a lot of research into this, and I've detected bugs or issues within the airplane that were there to begin with, but nobody knows about except for me. Okay, and this is considered to be, call it, the most resource-heavy type of technique, because I don't just take advantage of something that exists. I need to learn, invest a lot of resources in order to find something which is really unique. However, once I find it, it's really, really effective, right? Because nobody knows about it, and I can take advantage of it. And when it comes to, if we'll move away from Lockheed Martin from the example 1 second, we'll just look at this up in terms of software. It is very much the same when it comes to how vulnerabilities or how issues can come about in application security. When we talk about learning the aircraft, when we said that about the Lockheed Martin example, in our domain, it's called SBOM, Software Bill of Materials. So the first thing I'll do as an attacker, I will try to generate the SBOM of the application or the software I'm trying to attack. I will generate that SBOM. The SBOM includes all the components the software is made of, all of the versions of it, all of the known vulnerabilities that are attached to those components. So first of all, I will have a clear list of information, a very detailed list of information on what the software is composed out of. The tools in our domain that do this are what are referred to as SCA tools, software composition analysis tools. What these tools do is they, in a nutshell, they generate SBOMs. What they know what to do is get an input of a piece of software, and their output is an SBOM. So it's kind of, think of this as I don't know, a meat processor or whatever that processes all this information, breaks it all down, and gives you a clear understanding of what's inside that piece of software, which third-party components are in there, open source packages, commercial products, you name it. And then if I'm going about this realm of leveraging existing problems, there are either known issues, and as I mentioned, these are called CVs. These are publicly available CVs or identifiers that are published when somebody detects an issue in an OpenSea system version component of a specific version. When somebody detects it, it gets at some point in time gets published, and it is known for everyone. And what we refer to as new problems that are unknown to others but known to me as attackers, as the attacker, these are called 0 days. Why are they called 0 days? Because once they get exploited and people find out about it, it's the 0 day, first day, basically the first day or zero time in terms of from when it was discovered and published. These are considered, generally speaking, the most effective, the most hard to get by, but the most effective means of measure in order to attack. So why do you think that is? What do you think, for those who are less familiar, what do you think 0 days are much better to attack than CVs? So think of this as a kind of a double-edged sword in a way. So on the one hand, it's a very effective tool because nobody is expecting it. However, if I keep on using, if I have a 0 day that I've obtained in my possession, and I use it in an uncareful manner, it will get discovered. Somebody will figure out some point in time that there's something going wrong in the application. There's some weird anomalies or something like that, and then they'll detect the issue, and they will fix the issue, making the 0 day that I have in my possession nullified in the sense of the value that it has, right? So the general, I would say, assumption is that you can think of this as, doomsday kind of tools, right? So think about if you think about the biggest cloud nations on the planet, obviously including the US, but other forces as well, call it the West and the East, whatever you want to call this, the assumption is that they all possess those 0 days at their hands for a doomsday scenario. They are not using it on an ongoing manner because it's a high value kind of a tool that you don't want to burn out in that kind of sense. When we say third party, so there's two types of third parties. I can either use an open source package, which is again open source. Everybody knows about it. I can go into the code itself. I can contribute to the code itself. But it also includes commercial products. So think of a situation where I'm buying a software library for somebody to do something within my application. So third party, usually when people think about third party, they think about open source. The only note here is that it's not only open source, it's also commercial products that are integrated into my software. As I bought them, I have a license for them, a subscription for them, whatever the pricing model might be. So look at the supply chain, right? So we've thought about the supply chain of a factory by Lockheed Martin. This is an illustration, a very high-level illustration of a software supply chain and a typical CI/CD pipeline, right? So you have on the left-hand side, where the source end side, where people actually do their coding, they have the build system that they use for building, they have testing and automation, they store and they start and manage their releases, the packages, they deploy it close to wherever it needs to be deployed and installed, and then that piece of software is running in production. And in addition to that, you have what we refer to as the public repositories. These are open source public repositories for the different package managers, for Python, JavaScript, whatever they may be. These are pieces of software of open source packages and source that developers and CI/CD pipelines ingest, meaning that they use in order to integrate it within their systems, but it's outside, it's down the pipe from our own supply chain within our Artifactory. And so if you look at source and binary, the software that runs throughout the pipeline, in these areas, it's in the form in the state of source code. And then as it progresses through the pipeline, it becomes a binary, and then it moves on across the lifecycle. And of course, this is our pipeline. And of course, we have suppliers, and they have their own pipelines, and they have their own pipelines, and so on. So, and when you look at this from an attack vector, all the things that we talked about can happen across any stage at any time of the supply chain, right? So one example for this is somebody can come in and inject a malicious package, which is a bad, it's a Trojan essentially. They can plant something in a public repository and get my developer to use it. And then I have a malicious package within my organization, I have a Trojan. Or somebody, an attacker can identify CVEs in those open source packages or in the source code that we develop in the packages that we use inside our CI/CD and take advantage of it later on. They can detect zero-day vulnerabilities in the code that our developers code. They can detect those and later on go on attack production. They're not what this essentially means is if you look at the supply chain from end to end, from the developer workstation all the way to production, different types of attacks can and will happen across the entire supply chain. And our take on this with JFrog, first of all, is that if you cannot control your entire supply chain, you can't really secure all of it. So this goes back to Artifactory and what I assume you guys talked about a bit yesterday about Artifactory with promotion. The fact that we have Artifactory, which is the center of gravity of the CI/CD pipeline, that allows you to control which packages or which releases go into the binary management, but then later on go out from our repositories and into production, is a great gatekeeper. And on top of that, we are adding all of our security offerings, which I'll share with you in a second. So let me quickly, so I jumped, this is my final slide, but I want to go back to another slide before we wrap up. But this gives you a clear understanding into what JFrog has today in terms of its product portfolio for security. So we have solutions. Our solutions cover both source and binaries. We detect first-party vulnerabilities in their code and third-party vulnerabilities in their specifically in open source packages. We have a curation solution that helps them take care of it's some sort. You will have a dedicated session for this, but think of a curation as a firewall for packages. It allows you to allows customers to control which packages enter the organizations and which do not, but based on specific criteria. We have our own SaaS solution, which is static analysis security testing, which is our source code scanning tool. We have X-ray and advanced security, which is our SCA, software composition analysis tooling, in addition to contextual analysis and exposure detection, which you'll hear more information about. And you see this all the way on the right-hand side with runtime. Stay tuned for that. The fact is that we are building a runtime security product that will be launched later this year and will complete an end-to-end suite of solutions for JFrog security all in one platform. So this can help you with, replacing competitors, consolidation, lots of different values that you will talk about later on. I want to go back to just this slide. One sec. I'll do this quickly and then we'll wrap up. This is just call it our North Star in terms of how we operate at JFrog Security. All right. So what we try to provide with our customers is the ability to release software fast with trust and confidence. And we do this using 4 main pillars. First of all, we are research driven. We have a very big security research arm. This came in through the acquisition of a company called Vdoo, which happened about 2.5 years ago, or a bit less than that, which was JFrog's biggest step forward with its investment in application security tools. So we have a very big research arm. They all came in from a unit called 81, but it's essentially what we like to refer to as the NSA of the Israeli army. They are really top-notch individuals and experts. So everything is research-driven, and it's called the backbone of what drives our products. The second aspect is developer-oriented. We know that without having the developers play the game or be in the game with us in order to use our tooling and our security value, and nobody will use us. Adoption of security tools is not just about giving these tools to the security leaders. They want to detect all the issues. They want to make sure that you give them tools for developers that like using you. Otherwise, they will push back. The next thing is, we talked about it. We are both binary and source code focused. We cover the entirety of the supply chain. And this is, of course, all in one platform. These are not point solutions. Each of these products here, curation, SaaS, X-ray, advanced security, and runtime security, each of these effectively can be a startup of their own. But these are, on the one hand, solutions that solve for specific issues, but they are not point solutions. They are one of a single platform in combination with Artifactory, and that's one of our biggest strengths and advantages going into this category. With that, I'm at time. Ron, you control the time in terms of more questions, but I'm done with slides.